Ayan. So, let me see. This, okay. So when we tried defining what a group is, so we start with a binary operation. So the operation here can be either addition or multiplication. So when you're talking about addition multiplication, it can be ordinary or it can be defined something different. So in addition to a binary operation, a group together with the following properties: associativity, existence of an identity element for all of the elements in the said set, or in this case, G, and each of the element will have an inverse. So therefore, all of this, when they are identified as properties, so you will have a group. Kung may dadagdag tayo, if you will have a commutative binary operations, in others, pwede pagbalik na rin, so you will have an abelian group. So all in all, you will have a group, or in addition, you will have an abelian group. So we were able to discuss these examples. So go through lang natin. So R and Z under ordinary addition, these are groups. So we have examples of non-groups. We have the set of natural numbers under addition kasi wala tayong negative inverses. For multiplication, naalala nyo pa, well, andito na palang hint. For this to be not group, kasi we have 0 na walang multiplicative inverse. Okay, and a lot of others. So I believe you have this copy. All in all, I think we stop with, huminto tayo dito. Okay, medyo nagka-problema ako with my internet connection. So at this time, let's consider a set of matrix. So a matrix is just an array of values. In this case, I'll be discussing with 2 by 2 matrices. So collect all of them together, whose entries in this case, among entries mo A, B, C, and D. So if you will have this type of matrix, ang tawag dito mga real valued matrices. So puro mga real numbers ang A, B, and C mo, and put them in one set as a collection. So the question is this a group? And we were able to answer this last meeting, and we were able to identify that indeed this is a group. Closure, the sum of two matrices, which are 2 by 2 matrices, so it's still 2 by 2. So meron kang corresponding addition to each of the entries in the matrix. So in this case, for example, A sub 1 plus A sub 2 dito will correspond to the first row, first column entry in your resulting matrix. And you have A sub 1 plus A sub 2, and correspondingly. Associative matrix addition is associative. Ibig sabihin, if you have, say, for example, let A, B, and C be 2 by 2 matrices, if you will add the first two matrix together, A and B, together, and the third matrix, it's just like adding, yung resulting matrix ng sum na to would still be by adding the last two first, then added with the first one. So it's an associative operation, yung matrix addition natin. Identity, it's a zero matrix. And then finally, the inverse of the matrix is just the negative. Okay? So now, ang last question ko last time na nag-stop tayo, how about matrix multiplication? So if you can remember yung operation natin with the regular matrix, hindi na to corresponding wise multiplication. So meaning to say, what we're saying is that if you multiply A sub 1 times A sub 2, na sinasabi natin is this equal to A sub 1 times A sub 2, B sub 1 times B sub 2, C sub 1 times C sub 2, D sub 1 times D sub 2. This is not the operation we're talking about. Actually, although this operation may particular name ito, yung multiplication that is being introduced here, this is called, if I can remember, the Hadamard multiplication. So may particular way of doing the multiplication. In this case, component-wise. Pero this is not the multiplication we're talking about right now. So the usual na matrix multiplication. So I believe tama ba, Joshua, last in your matrix algebra or linear algebra, you learned about matrix multiplication, no? I think yung audio mo, Joshua, I cannot hear you. Tama ba yun?
Yes. Ito po.
Ayun. Yan, good.
Ayun. Ito po.
Yeah, I can hear you now. So were you able to learn matrix multiplication last time?
Ito po.
Okay, good. All right. So now, so gagawin natin, the question is this a group? Well, surely we know that your matrix multiplication is a binary operation. So we're talking about that your M sub 2R is closed under matrix multiplication. In other words, what we're saying is that your matrix multiplication is a binary operation. So we don't have problem on that. But the question is that, sorry. But the question is matrix multiplication satisfying the three properties of the definition of the group. So let's start with associativity. Umpisa natin yung associativity. Associativity. Well, what we can do actually is we can assign three matrices just for the purpose of doing the operation kasi we're dealing with matrix multiplication. So if we consider, say, A sub 1 to be A sub 1, B sub 1, C sub 1, and D sub 1. Tapos let's consider A sub 2 to be the matrix A sub 2, B sub 2, C sub 2, and D sub 2. And then finally, A sub 3 is equal to A sub 3, B sub 3, C sub 3, and D sub 3. So the question is, can you tell me, Joshua, if I'll multiply first the two matrices A sub 2 and A sub 1 and A sub 2 together, and A sub 3 on the left, is this equal to A sub 1 times A sub 2 times A sub 3? So meaning multiply mo ang A sub 2 and A sub 3 first, then multiply from the left yung A sub 1. Can you do that? Do you have a scratch paper naman dyan, no? Can you...
Pwede ko po i-annotate mo dun sa screen, I think.
Yeah, sure. You can share your screen.
Wala. Yung option. Wala.
Yung pen.
Kasi gawin kita co-host para at least you can share. Ayan, so. Stop ako Stop sharing ako.
Apo, wala po palang annotation anyway.
Ayun.
Yun.
Good.
Oh no. Kasi yung ginawa dito, I actually don't know. Basta last sa ano po yan, wala nga po tong sidebar.
Okay.
Kaya po yung share na po ako ng Jamboard.
Sige. Are you using the mouse ba to do this?
Pen po. Yun pong...
Okay. May pen din. That's good.
Pen.
Oo. Oh no. Ayan. Anyway, so new board.
Okay.
Mhm.
First row, then tapos first column. Ayan. Okay, good. Ayan. Good.
Dito is
Okay, good. Ayan, correct. Okay, nice. All right. Correct.
oo, wait lang
Oh,
po.
wait. May last second term.
Yan po.
Ah, check mo ulit yung, ayan, computation na yan. Ayan. All right. Okay.
5 times. Wait lang po. Oo. Yun. Hmm. Hmm.
Right. Ayan, medyo malaki-laki matrix yan.
Hmm. 3 times that. A1, A2, A3. Four.
Okay. Check mo kung if it's B sub 3.
Wait lang po. So, ito
Sure,
na lang.
sure.
So,
Ayan. This good. Yan.
okay. I don't think ganun. Anyway. So, dito na first. A1, A2, B1, C2, tapos yung dito, A1, B2, okay.
Tama.
Dito na. So, A1, A2, B, C2.
Okay. May na-miss ka.
A1,
Actually, if you look at your product, may dalawa kang ano, di ba? On your left, you have 2 entries sa rows mo. Okay yung first 2 terms mo, but you're expecting additional 2 terms eh. Yan, with A3, correct? Plus the product with C3. Yeah.
Okay, okay. Yan ba? So,
Yun.
last one.
Ayun.
Dito.
So medyo na try to look at ano, yung first mo na ano, computation, last 2 terms mo.
Dito ba?
Oh yes, last two terms, John. So check mo muna. So A sub 3 is multiplied to the first two. So okay lang yan. So C sub 3 must be multiplied to the next two. Ayun. Yan, that's good. Okay.
A1. Pareho-pareho. Same thing. So, A1,
Mhm. All right. All right. All right.
A1, B2. B2D.
Yan. Correct. Then the last.
B2D3.
All right. Okay. Last two entries.
So, C1, A2, A3. B1, C2,
Mhm.
A3 plus
All right.
B2, C3,
Okay.
B1, B2, C3
All right.
is C1, A2, B3, B1, A2, B1, B1, C2, B3,
Okay.
B1, no, this is CB.
Mhm.
B2,
Okay.
D1, D2, D3.
And D3. All right. Okay. That's the left-hand side. Can you work out on the right-hand side naman?
Yun nga po. So, wala na yata lugar dito. I'll just copy paste this.
Maybe on the other, ano na lang,
Opo.
other paper. Hindi
Oo.
siya ano, no? Hindi siya parang scroll.
Opo, hindi po. Ano po? by frames po siya.
Okay. Hindi ko pa ito na-try ang ano, Jamboard.
Ano po siya easily accessible pero on October 1 mawawala na po siya eh.
Sayang naman kung ganun.
Kaya nga po kasi yun hindi siya may mga ibang board na mas maganda kaya lang they require yung faster internet po.
Okay.
Na-try niyo dati ginagamit po namin ano kasi dati Josh?
Ano lang.
Sa Microsoft Teams ginagamit natin.
Envision.
Envision po maganda.
Okay.
Kaya
Ito,
lang
kasi yung
hindi
sa
na
akin, nasanayan ko na itong ginamit. Nalimutan kong pangalan nito, Note something.
Notepad po.
Notepad.
Notepad. And I paid lang yung ang version niya.
Po, yung pong Envision dati nung pandemic kasi free. Hindi na po siya free kasi hindi na.
Okay, let's look at the last. Yan. Tingnan natin. Would it work? Actually, the answer is yes, it would work.
Opo. Alam ko po meron po siyang identity. Meron din, associative din siya. Yung
Yes.
inverse, meron din po, I think. Kasi
Yan.
sinasolve po yan using yung Gaussian, elimination.
Yes, tama. So it's
Pero,
either Gaussian elimination or Gauss-Jordan.
opo, yung ano lang po, yung proof na lang.
Okay. So we'll just cut na lang dito. So for this, if you will work this out, magiging pareho lang, pero at first you might look at na hindi sila magkapareho. But if you take the product, the left-hand side will be equal to the right-hand side. So I just want to look at kung anong skill mo na sa matrix multiplication. At least you have the skill naman. So I'll just leave this to you as an assignment to work out, or maybe just an exercise to work out na hindi na magkapareho yung right-hand side, left-hand side.
Opo.
Okay. So, tatapusin lang, later mo na lang tapusin, Joshua? Will
Opo.
that be okay?
Opo.
All right. So
Capture mo.
now we're done with the associativity, pero let's look at, let me see. Let me share my screen now. So indeed, we have an associative multiplication. The answer is actually yes. So erase ko na lang to. And the answer is indeed yes. Pero for the identity, what do you think would be the identity element in the set of matrices?
1, 1, 1, 1, 1, 1 yung ano po, yung main diagonal po sa
Yeah,
0.
that's correct. In this case, ang identity natin is 1, 0, 0, 1. So main diagonal are all ones. Or in general, kasambot lahat ng diagonals are all 1 and the rest 0. So ang upper triangular, lower triangular part of the matrix are all 0. So if you multiply all of this, just to verify, quick verification lang, since for any matrix A, B, C, and D, and if you multiply this matrix 1, 0, 0, 1 by the operation itself, so you will have still A, B, C, and D. So you can easily verify. But may last question. The question is for the inverses for each of the elements. So are we saying that for every matrix A, in the collection of 2 by 2 matrix with real parts, will there exist, let's call this inverse A inverse, such that if you multiply A with A inverse or A inverse with A, it must be equal to your identity matrix 1, 0, 0, 1. Totoo ba to palagi for all of the inverses? So ang question ko muna, from your experience with matrix algebra or linear algebra, if your A is of the form A, B, C, and D, ano yung A inverse as a matrix?
Ang nga po to, meron po siyang meron po siyang parang negative something.
Yes, para may formula yon.
Opo.
So I'll give you an advanced formula na lang, but this
Negative.
formula can be derived in linear algebra. For 2 by 2 matrix, you can use yung sinabi mo kanina, Gaussian elimination or Gauss-Jordan elimination. So pwede mong gawing any two of the methods. Or kung medyo advanced ng linear algebra mo, you will be using cofactor matrices
Opo.
na kukuha ka ng determinant muna ng matrix. So ang determinant nito, ng matrix na to, naalala mo pa ang determinant ng 2 by 2 matrix?
AD minus BC.
That's correct. So the determinant of A is equal to AD minus BC. It's actually ang determinant, from the word determinant, it determines something. In geometry, it determines some scaling factor. Sa ibang naman, gumagamit siya later for eigenvalues and eigenvectors. So later na lang natin pagdi-discuss yan. So in this case, yung inverse na matrix mo will be of the form. Actually, ito yung magiging itsura niya. You have a multiplier 1 over the determinant of A times the matrix, babaliktad ang A and D. So you have a D, you have an A, tapos a negative B and a negative C. Kung tama ako I think yan. Magbabaliktad lang A and B. But from this formula of an inverse of a 2 by 2 matrix, question, what makes matrices not having an inverse? Anong klaseng mga matrices na walang inverse?
Alam ko yata po yung parang wala yata silang wait lang po. Parang see. I think it's the same rule for yung mga row reduced.
But particularly, ito Joshua, observe this matrix. Sabi daw natin, for a
determinant A is equal to 0 po.
Yan, that's correct. So from this, mapapansin mo kung ang determinant mo 0, imposible ka magkaka-inverse. So in other words, actually in general, this is true. A has an inverse, or in term natin na gagamitin, invertible, if and only if your determinant is not equal to 0. So totoo to palagi. There's a proof of this in linear algebra that tells you that this is always true. So in other words, yung 2 by 2 matrix natin na M sub 2R includes matrices na may mga determinant is equal to 0. Can you give me an example? Example lang of a 2 by 2 matrix na ang determinant niya is 0.
2,
So 2,
2, 2, 3, 3 po.
2, 2, 3, 3, yeah. So you will have 6 minus 6 is equal to 0. So this is an example. This is in M2R, pero matrix na yan, wala siyang inverse. So in other words, we will remove these matrices and let's try to define a subset of M2R. Let's call this subset actually GL2R. GL stands for actually later generalized or general linear. Okay, yung M dito obviously stands for matrix. So ang GL dito stands for general linear, which is a subset of M2R, and particularly in GL2R natin, we will specifically choose matrices A, B, or kahit hindi na natin susulat A, B, C, D. Sasabihin na lang natin a matrix A na 2 by 2 pa rin, pero at this time, specifically, we define the determinant of this matrix A must not be equal to 0. Or in other words, kung gusto mo siya talagang specific na isusulat natin, so if you define your A to be the 2 by 2 matrix A, B, C, D, such that tapos ang A, B minus BC must not be equal to 0. So ayun. So this is a special kind of matrix. Later, may gamit ito sa quantum mechanics. So just for trivia lang to in general, the study of quantum mechanics is just like studying linear algebra, because in the 1930s, when it was discovered first by something known physicists noong unang panahon, particularly si Planck, from the Planck's constant, Heisenberg, von Neumann. Actually, it was Heisenberg na nakita niya ang properties pala ng mga quantum operators are actually matrices. So kaya when you are studying quantum mechanics, you're just like studying linear algebra and vice versa. So later may connection yung dalawa na doon, but in history ito yung parang trivia out of this. So this type of matrices, itong interesting dito kasi what we are dealing with, these are the matrices now which is a group. So in other words, we defined earlier M2R, this is not a group kasi may mga matrices ka under multiplication. Pero if you restrict all of the elements having inverses, and let's call this GL2R, together with matrix multiplication, this is group. Okay? Or in general, kung gusto mo talaga in general, for any n by n matrix under matrix multiplication, this is a group. Okay? So let's explore that later. Yung mga groups na to under under matrices. So we will be reviewing some of these later. So for us to the matrices, Joshua, do you have any questions before I'll proceed to another example of a group?
Wala naman po.
All right. Now, if you have read chapter 1 of Gallian's book, Contemporary Abstract Algebra, you have already encountered this. Let's call this collection D4. Ayan. This is the collection of, this is called the dihedral group of order 8. Okay, so let's explain. Ano tong dihedral group of order 8? Let's start with a square. Let's start with the square. Sorry medyo I'm not good with horizontal lines kung nasa tab. Ayun. So, let's number each of the vertices as follows. Some vertex natin, dito na lang ako magsusulat ng number sa loob. Let's call this 1, and let's number this counterclockwise. 1, 2, 3, and 4. And let's associate this numbering with some expression r raised to 0. R here will stand for rotation. Rotation. Okay. If you rotate this square counterclockwise, so in this case, i-rotate ko siya as, again, magdodraw ako ng another square. So counterclockwise, ang 2 mo maging 1, ang 3 mo maging 2, and so on. So it's a rotation of 90 degrees. You can imagine this na ito yung parang meron kang butas sa gitna, then you pin it, then you rotate the square. Dapat ang kakalabasan niya is also a square. So you're rotating this 90 degrees. Let's call this R1. So obviously, parang ibig niyan sabihin, you're only rotating it once. So therefore, if you're rotating it twice, ano yung magiging outcome ng numbering ng mga vertices ng square na to? So what will be the one stance? Where will be the one?
Top left mo.
Dito, sa upper left, 1, 2, 3, and 4. Okay? Then, kung magro-rotate ka ng 3 times from the original square, so therefore, let's do the numbering. Right? So next, so where will be your 1? Obviously,
Nasa bottom left mo.
yan. Ito, 1, 2, 3, and 4. All right. So my question is, what is R4?
Rotation lang po.
From the rotation lang, ang R4 mo. So therefore, it will go back to the original square na meron ka. So therefore, what we're saying, ang R4 mo
R4 is
equal to
R0 po.
R0. So how about R5?
Nasa R1 mo.
Still R1. So in other words, rather than writing again, writing R5, R4, R5, R6, and so on, it will just go back. Parang may cycle ka, babalik lang siya sa original form. So likan, rather writing R4, 5, erase na lang natin. So therefore, magsa-cycle lang siya. Now next, let me introduce F. F stands for flip. If i-flip natin. In my case, I think ang flipping na ginawa ko, ito. So gagawin mo is that we will be flipping R square. Ito yung square natin. 1, 2, erase ko naman to 3, 4. Tapos if i-flip ko siya along the diagonal. So parang gano'n, flip na transpose. So therefore, the resulting square will have the following. So fix si 4 and 2. Tapos magsi-switch lang yung 1 and 3 together. So you'll have 1 and 3. Okay. So you will have a new numbering of the matrices. Napansin mo, iba siya from the others. So what we are looking at, as much as possible, let's try to look at the arrangements of 1, 2, 3, and 4 within the vertices of the square. So the question is, how about if I'll flip the square first, tapos i-rotate ko siya once, what will be the resulting square? If I'll flip the square first, then rotate the resulting square twice, and flip muna pala, flip the square first, tapos i-rotate ko siya thrice. By the way, napapansin nyo, from right to left yung action na ginagawa natin. Because we will understand this, you can imagine this as functions. Naalala mo yung composition of functions?
So
That the composition is from right to left.
Opo.
Ayan. So the question is, anong mga resulting square meron tayo? The first one.
1 nasa bottom left, tapos clockwise 2, 3, 4 po.
Okay, great. Correct. Okay. Tama. How about this one?
Bottom right po yung 1, tapos clockwise po.
Alright, correct. Okay, and then finally,
Top right na po yung 1.
okay, top right ang 1, tapos 2, 3, and 4. All right. So are all of these squares different from each other?
Mabo.
Ayan. So, my question, itong gagawin mo ngayon. So at this time, what if you create a multiplication table or a Cayley table out of these elements? So meaning kung i-gather around ko ito as the collection R sub 0, R1, R2, hindi pala sub R3. Tapos, by the way, I can either write this as F or pwede ko siyang isulat as, para at least to be formal, R0F. So meaning to say, what we're saying is that you flip it first, pero you did not rotate it. Parang ganun yung ibig sabihin dito. So, and everything. So, my question is, I forgot to write R1. Back ko lang. Back. R1. By the way, lakihan natin. R2, F, and then R3, F. So, my question is, well, I already mentioned earlier that this is a group. Can we show indeed ba it's a group first? Is the action of all of these squares a binary operation? So let's have to generate a Cayley table. At tignan natin kung makaka-generate tayo ng Cayley table. Let's see. So, hatiin natin into 2. 1. Right? And so, okay. So let's write the following: R sub 0, R1, R1 pala, R0, 1, R2, and R3, R0F, R1F, R2F, and R3F. And then finally, yung rows natin are the following: R0, R1, R2, R3, R0F, R1, R2, and R3. I'll just erase the remaining lines para at least. Ayan. So,
Di po siya square. Yan.
Ayan. So, although hindi siya nagmemukhang square. So, can you fill up this table? Tingnan natin muna. At madali lang to yung una. Yung this side.
Unang row po, wala nangyari po.
So, ang unang row, walang may nangyari. So, let's write this down as, I'll just write this as black. Okay. And, so, R0, R1, R2, R3, R0F, R01, R1F, R2F, and R3F. Okay. Ano pa?
R1, pag R1 po, R1, R2, R3, R0.
Okay, that's correct. R1, R2, R3, and R0.
Tapos
Ayan.
R1F, R2F, R3F, R0F po.
Again?
R1F, tapos
R1F,
R2F,
R2F, R3F,
and then R0F po.
R0F. Ayun. Actually, kung iisipin mo to, parang you're doing the same thing. Parang you get a paper, cut it into a square, put a number, then try to do the rotation from right to left. Pero at the same time, you have seen the pattern na parang you're adding the exponent. Okay.
Opo,
How about
tapos
the second one?
mag-modulo na lang po siya by 4.
Okay, so you will have R2, R3,
0,
R0, and
1. R1 po.
R1. Okay, how about this second?
R2,
R2F,
F, R2, R3F, R0F, R1F po.
R1F. Okay, correct. Then finally, this one, first, fourth row, R3, R0, R1, R0.
2,
So magiging
R2 po.
sorry, R2, sorry. This would be R2. Ayan. Next,
R3, R3F, R0F, R1F, R2F po.
R1F, R2F. Ayan. How about this one? Ito. Dito lang muna tayo concentrate para at least ito muna. Ayan. Ano magiging result dyan? Ito,
R0, opo.
Maglalagay
Maglalagay lang po ng F sa
Okay.
first 4.
So the first 4, ito madali to. Kasi it's just R0F, R1F, R2F, R3F. Okay. So wala may nangyari on the right-hand side. How about these? Ito, yung side na yan. So for example, ay sulat natin ha. How about say R0F and then R1. So anong magiging result nito? Parang sinasabi mo, si R0 wala naman mangyayari, so we can rewrite this as FR1. But the form what we are looking for is actually mauuna si R, huli yung F. So how can we write it this way?
So,
I-draw muna natin. Can we draw this? Ano bang itsura nito? Anong itsura niyan? Para
rotate first and then flip.
So, rotate mo daw ito. Then, sulat natin yung original. Ang original natin, 1, 2, 3, 4. So, magiging, rotate mo na, tapos, flip.
1, 2. So, 4, 1, 3, 2 ba?
Ayan. So, therefore, rotate mo siya, di ba? Maging 1, 2, 3, 4. Tapos, magiging 4 dito, magiging 2. Okay? So, that's how it's like. Diyan nakuha?
Abo.
Ayan. So, anong andito sa list natin na pareho dito? Take note again. 1, 2, 3, 4. So, dito sa list mo, 1, 2, 3, 4. Saan dyan?
R3F mo.
R3F. So, therefore, what we're saying, this is also equal to R3F. Hey. One more, para at least makikita mong pattern. Let's have, say, R1F, say R2. Ayan. Ito medyo a bit scary. So magro-rotate ka twice, mag-flip ka, then rotate again once.
So, dapat ano ba na? FR3?
So, this would be, tingnan natin, if this is FR3. So, mauna si F. Sulat ko lang. Oh, sorry. Saan na yan? Wait. Ayan. So, you're saying that this is FR3. Oh, you can try the rotating. I believe mapipicture out mo siya, no?
3, 4, 2,
Ako
1.
personally, di ko to makaya mentally, isusulat ko talaga siya
3, 4, 2, 1 po.
3, 4, 2, 1. Saan ako mag-umpisa ng 3?
Sa top left po.
Top left. 3, 4, 2, 1.
Hindi po. Talagang
Hindi.
left to right pala po yung sinasabi ko. Bilang mo. So, 1, 2, 3, 4. No? So, 3, 4, 3, 2, 1, 4 po kung clockwise. Kung counterclockwise.
3,
2, 4,
3.
3, 2. Hindi ba? Yung 3 po nasa,
Sabihin,
bilang mo. So, yung 3 po nasa top left. Tapos, yung going counterclockwise. That's
sa ilalim.
3, 2, 1, 4.
Okay. So try natin. Ako personally hindi ko kayang ginagawa. So I have to write it down. So
Opo.
R2 muna tayo. So sulat ko muna si R2 ha. R2 so magiging ano to? Si R2 natin magiging so dalawa 1 2 3 4 tapos i-flip ko si R2 magiging flip ko si R2 magiging 4 pa rin to si 2.
Okay. Magro-rotate pala po after the flip mo po. So,
Ayan,
magro-rotate. So, bali
finally,
for, ano po na?
rotate 1, 4, 3, and 2. Tama ba?
Ayun, yun mo.
Ayun. So, correct ko lang to ha. Correct ko lang siya. Ayun. 1, 4, 3, and 2. So, anong kapareho dito sa taas? 1, 4, 3, and 2.
1, 4, 3, 2. R3F. R3F.
R3F. Okay, R3F. So, sulat ko dito. Oops. R3F. Oops. Ayun. So, what pattern have you seen? Sa dalawa na to, may pattern ka na ba nakikita?
Ano po natagan? Yung kalabasan nito is FR1 po sa taas, naging R3F.
Yes.
Ito naman, bali ano siya? FR3 ba siya?
Oo. But
FR3
we
po siya.
say, yung
Also,
ginawa natin is this. R1, F, R2. So let's use associativity muna. So let's associate R1, ang F and R together muna. Ito. Tapos may technique dito. If you switch F and R together, ang mangyayari, this would be R inverse 2 and then F inverse. Meaning to say, isi-switch mo sila, ito yung parang magiging operation ng switching. But after flipping once, mag-flip ka ulit. So anong flip inverse niya?
pag ganun po.
It's the same, di ba?
Opo.
Babalik lang siya sa original niya na flipping. So si F inverse mo, flip pa rin yan. And then, if you associate this together, ayun, ano yung anong kakalabasan dito? Sabi natin earlier, we only take the sum of the exponents. So magiging
R negative 1F.
F. But the negative ngayon, since we are rotating counterclockwise, so magiging
Clockwise po. So, 3.
3. So ayun. So magiging R3F. So that's the reason, ito yon, R3F yung una ginawa. So similarly, ganun din, ito pala, ito, R3F. So the same operation, pwede na mong gagawin to be able to come up with all of this. So makukuha mo na siya actually. So ano nga kaninang nagawa natin? R3F ito.
R0F, tsaka yun.
At tapos ano kanina? R1F and R2, R3F din ito. So how about this one, Jan?
R2, R0F.
Ayan. Correct.
So babaliktad naman po yung parang ano niya.
Di ba meron kang R negative 2 mangyayari? So R negative 2, it's just the same as R2.
Abo.
How about this one?
R negative. So, bali, R1 F po.
Ayan, R1F. Okay, how about this one?
So, R2, R1, R1, R2, R2F.
R2F. Okay, correct. Next. How about this? By the way, nakita mo na lahat eh.
R0F po.
Ayan, R0F. Okay, next.
R3F dapat.
Ito? Sorry, ito ba?
Abo. Wait lang po.
R3F. Pero kung tingnan mo,
Wait lang po. So,
check ulit.
R1 tapos yung R2F. So, so F negative 1. Okay, F negative 2. So, F negative 1. R negative 1. So, R negative 1 is R3. Hindi ba po R3F?
Sulat natin para at least ano. R2F, R1. So, R2F, R1. So, associate mo together R2,
R2F, R1.
F, R1. Tapos, magsiswitch si F and R negative 1F. The exponents?
R1F.
F. Ayun, R1F. So, magiging R1F ito. R1F.
So, next is
Ayan.
R0F.
R0F. Correct.
Tapos ang R3F po.
Yan. Normally, titignan mo, ay, ano pang kulang dyan? In other words, ito, may mga kulang na yan. So, this would be?
R0F.
And then this one?
R1F, R2F po.
R2F. Alright. And then finally, anong ini-expect mo dito by the way? Ang last na to, ito, yung side na yan. Ano mga maging itsura niyan?
Kung R0F, wala nangyari, flip. R0 po.
By R0. Alright.
Kasi paano yung flips po, when they will cancel each other out.
Yes, tama. Flip first, then flip ulit, babalik lang siya. So magiging original lang siya na shape, R0.
Tapos yun yung sa R1F tsaka R0F. R1.
This one would be, tingnan ko lang sorry.
Okay na mo.
Ako din, tinitingnan ko siya. Hindi. Ano
So,
siya?
rotate, flip. Tapos flip.
Sulat natin dito. R0F, R1F. So, R0F, R1F. Let's apply the operations. So, you group together. Ito, R0F, R1F. So, if you flip the 0 and the F and the R together, R negative 1, magiging F inverse F.
Tapos R3 na lang po yun.
Yan, this becomes R3 and then this is just FF. So pareho lang na R0. So therefore, R3. So this one, R3. Ayan.
R2.
R2. Tama?
Tapos R1.
R1. Okay. Next, how about this one?
Mga pareho yan na tapos siya sa first part of the. So R1, R2, R3, R0 yata mo.
1, R2, R2 ba siya? R1, R1. So magiging negative 1. Tama, R2. Sorry. R3.
R0.
Okay. And you will have R0. Tingnan na natin. Just to double check.
R1F.
RF1 and RF1. Ito. Double check natin to. Kung tama to. R1F, R1F.
So R1 R1, FR1, F.
You imagine the F and the R in between,
Oo.
in the middle is ano mo, switch mo.
So, R1, F -1, R -1, F -1, tapos ano yung ano, F -1, R -1, F. Dapat magka-cancel yun.
Oo, cancel sila. So therefore, ano matitira?
Yung R0 dapat.
R0 dapat. Okay, so let's erase this. This becomes R0. So therefore, ito ay magiging R2. Double check na
Tama.
natin yung
Is it
pangalawa, negative. O, tama, R2. Ayun. Okay, how about this one? Ang sunod. Ito, mabilis to. And this
R2?
one. R2. So therefore, sa baba, ito, magiging
R3.
R3. How about this?
Okay. Baka R1 mo.
R1.
Tapos
Sunod,
R2.
R2 ito. Okay, next.
R0, R1.
R0. So we will have R1. And then finally, obviously,
R3, R0.
R3, R0. Ayun, we're done with the Cayley table of the dihedral group. So my question, what's the identity element?
R0 po.
R0, it's the identity element. Ito yan. Right, this is the identity. So sure tayo niyan. How about the inverses of each element?
The inverse of R1 is R -1. So R3.
R3.
Tapos
Makikita mo yan sa table actually.
Ako.
When you take the product of the two, it must be the identity element. So in this case, ito yon yung sinasabi mo.
which one will sum up to R0?
Ayun, tama. So the rest, ganun din. Makikita mo lahat ng mga inverses due to the product of having an identity element. So in other words, ito yon.
Each column has an R0 po.
Yan, lahat ng may mga R0. So they are identity inverses of each other, yung product nila. Nice, di ba? Makikita mo rin yan sa
Kita po siya. Labo.
Ayan. So do you have any questions dito sa dihedral group so far?
Wala ba po?
By the way, babalikan natin ang dihedral group later. When we discuss about subgroups. So pag-uusapan natin yan mamaya. So next group, I think this would be the second to my last group to discuss with you before we proceed to some of the properties of the group. Let me define my last group for tonight. Ito, ang last group natin ay yung UN. Oh, sorry, I'll use the blue pen na lang. Okay. U of N. Okay. In your book, this is the set of all positive integers less than n and relatively prime to n. Can you recall what's relatively prime? If two numbers are relatively prime,
Wala pala po yung kumaga if you take their quotient, it would be so ano kasi wala po silang common factor basically
okay, except
1.
So in other words, if you take the greatest common divisor of these two numbers, it must be equal to
1.
1. So in other words, any member, kung isusulat natin dito as a collection, A is a collection of all positive integers. So positive dapat siya ng mga integers, such that your A must be less than n and the GCD of A and N must be equal to 1. Okay? By the way, in some books, rather than writing the word GCD, sinusulat na lang nila yung open parenthesis a and 1, it's equal to 1. Parang in number theory form, rather than writing GCD, parenthesis na lang. Kung LCD naman, brackets yung ginagamit. Bracket o braces? Brackets pala. Brackets. So in this case, susulat ko lang ang word na GCD. So my question is, let's start with U10. U10 muna tayo.
Pala po, if I remember correctly, I think the number of this yata po, Euler's totient function yata po.
Yes, the toy tent function or the Euler's formula na that is being ano nga yung nalimutan ko yung formula na yon eh. 'Di ba these are related to the sum the number of divisors tapos sum of divisors, yung ito yung third na formula na napakaganda sa number theory. So later actually gagamitin natin ang formula hindi ko siya maalala ngayon. But later isusulat natin para at least we will be using such a formula. Okay? So now, let's consider, as an example, U10, pero ang binary operation natin na gagamitin is the multiplication modulo 10 or the remainder after dividing it by 10. So question muna, anong laman ng U10? What are the numbers relatively prime to 10, less than 10?
3, 4, no, 7,
7,
9.
9. May kulang ka pang isa. Yung relatively prime siya to all.
1 po.
1. Okay. So meron kang 4. Okay, kaya I think ang toy tent function na yun may +1 palagi. They have to add palagi because of 1. All right. So now, question. Let's now create or construct the Cayley table of this 1, 3, 7, and 9. 1, 3, 7, and 9. And let's consider the product, the modular product 10. Ayan. And
standard po siya pag nilagay na po subscript sum number is the operation tapos ang modulo that number po.
Standard in mathematical text?
No po.
In some standard, pero sa iba hindi. Like for example, if you have noticed sa kay Galian, wala siyang symbol na ginagamit. Sometimes, alam mo naman mga mathematicians, the symbols have been created for the purpose na tamad na sila magsulat ng mapakahabang statement. For example, medyo ano lang tayo. For example, ang kanina, when we define the identity element, di ba, there exists an A for all B such that A times B, say it's equal to the identity element. So ito, rather than writing the word there exists, writing the word for all, well, for the purpose of lectures right now, so we use the symbol. Pero kung magsusulat ka na ng mathematical text, for example, you're typing it in a computer, rather than writing it as a symbol, mas matagal pa, hahanapin mo pang symbol, except naglalatek ka. You're familiar naman ng LaTeX, yung ginagamit sa
yung ano po yung
formatting?
Yung mag-ano po kayo talaga ng HTML po.
Yes, so yun. Maggagamit ka ng mga codes. Kasi mabilis yun kung mag-ano ka ng code. Pero kung nagsusulat ka sa like Word, for example, you would rather write it as there exists, you would write it as for all, kasi mas mahaba siya, mas mabilis siyang gagawin. Yun lang naman ang purpose of having the symbol. It creates an environment na napaka ano to? Jam-packed on a very limited space with so much information. By the way, for the purpose of logic, pareho lang ba siya as to saying na for all A there exists a B, or not so for all A? For all B there exists an A? Are these two equal?
No.
No.
For all A, yung ano taga yung rini-restrict na po yung ano, yung existence ng B. Pero yung sa ano
Yes.
po, yung sa second statement, rini-restrict na po yung A.
Yes, that's right. So parang sinasabi natin sa first statement, may isang A, at least may isang A para sa lahat ng B. Sa pangalawang statement, you're saying, sa lahat ng B, meron kang A sa bawat B. Parang ganun ang ibig sabihin. So that's good. At least you get it, na meron ka ng notion na ganun na magkaiba sila. Because some
Opo.
of the students sa college, hindi yun nagigets. Hindi nila nakukuha na, ay, magkaiba pala sila. Akala nila magkapareho. Alright, so let's fill up the table muna for this. Well, ang
Opo.
obvious, pinakamabilis, yung 1.
1, tapos 3, 3, 7, 9, okay. 3,
Ayan.
9, tapos 9, 1, 1 sa ano po, kabilaan.
So dito, how about this one? Kabilaan,
27,
kabalaan, tama, 1.
opo.
Naman,
7, tapos on
7
the
din
other
dito.
side din po. Tapos 9. Bale, ano lang po na, units digit. Units digit po ng
Yes.
mga ano, 9, tapos uh, 3, 3.
Yan. Anong
Tapos
missing?
1 po.
So you
1,
miss what? 3
3,
dito,
3, 1 po.
1. Okay, that's correct. Now, can you identify the inverses for each of this?
Yung identity po yan, the identity is 1 ba?
Obviously, the identity elements are the ones.
So, yung inverse ng 3 is 7, the inverse of 9 is itself, the inverse of 1 is also itself.
Okay. So in other
Yep.
words, nakikita mo lahat-lahat dito that indeed it's a group. So it satisfies associativity. And we were able to discuss this last time kasi underneath ng multiplication na to is just the ordinary multiplication. Kukunin mo lang yung the remainder ng multiplication na yon. Second, we have the identity element. Third, we have the inverses. Inverses. But and then obviously this is product natin is a binary operation. Kasi lahat ng mga numbers makikita mo are in U10. All of that are in that set. So we cannot have problems on that. But my question is, in general ba, if you generalize this,
UN po.
UN na. Question, is this a group?
So, it's definitely a binary, yung hindi pala yun po yung alam. Yung is definitely associative. It has an identity. It has an identity. 1. Yung inverse, I don't know, probably. Pero yung pagiging binary operation, okay.
Yes. So
Hmm.
inverse ang tanong, di ba? We always talk with, ang inverse ba? Totoo ba yun? Na meron siyang palaging inverse? In this case, actually we can prove. Pwede nating mapuprove yan. So we are to show, gagamit na lang ako TS to show that for every element, say tawagin natin, anong element na gagawin ko? A na lang. For every element in UN, there will exist an inverse in UN such that it satisfies the definition of inverse. So A times A inverse, by the way, times natin dito is just the product, the modular product under modulo N. Inverse
Okay.
must be equal to, of course, the 1, which is our identity element.
Ano pa pala, yung times niyo po, n po. Multiply n.
Yes, yun. So,
Hindi po, yung sa second ano po, second argument.
anong second argument?
A inverse times, tapos may subscript n po. Subscript n.
Sorry. Ayan, may N, ayan.
Yan po. Equals 1. So, A times A negative 1, okay, equals 1. Modulo n.
Ito, I'll give you a hint. So let's call this rather than A, gawin ko na lang B to sorry. Gawin ko yan B. Erase ko muna to. Rather than A yan, A inverse pala, gawin ko yan siyang letter B. B. B ito, B yan. So, anong definition na, if you can remember, if you have A times B under modulo N, this is just equal to saying, ang sinasabi lang natin dito, this is A times N, A times B, modulo N. Yan ang gusto lang natin na ilalabas. Dapat, it must have a remainder which is equal to 1. So, from here, tanong yan, it's, anong definition nga ng modulo? Remainder. Mathematically, maisusulat natin ito this way. We're saying that N divides AB minus 1. That's the definition lang ng modulo.
So therefore po, B must be equal to, there must be a B na AN minus 1 po. Ay, AN plus 1.
Yun. So what we're saying, parang there exists, gamitin lang nating letter T na lang, no? Which is an integer such that AB minus 1 is equal to some NT. Parang ganon. Parang that's how we write this down. Or we can write this as AB minus NT is equal to 1. Okay? But, napapansin mo, or although kung gusto mo talaga isusulat natin to, AB plus N times negative T para at least is separate na integer siya. So my question is this. Si A mo, if we claim that if A is in, and B is in UN. Ayan. So, dalawang numbers na to are in UN. So, anong ibig niyan sabihin?
Or ano po is, are both A and B relatively prime to N?
Yes, that's correct. So, we're saying that, in this case, A, B is relatively prime to N. So, isulat lang natin dito as GCD of A, B, and N is equal to 1. Okay? So, kasi yun ang gusto nating ipapakita. But, in this case, can you somehow show na indeed this is true?
So, ano po, AB is equal to, ano po na, ND plus 1 by
Okay.
kaninang, ano, so, so, NT over N cannot possibly be, ano so, pag NT over N, that's equal to T plus 1 over N. Paano kasi mag-proof po? So anyway, T plus 1 over N is not an integer.
Okay. Maybe we can rewrite it this way para at least, although nagsulat ako dito ng formal proof for each of this, kasi what we want to show is this, parang from the idea is we know si A is relatively prime to N. So therefore, the only divisor lang ng dalawang number na to, it's 1. Tapos, ganun din si B, relatively prime to N. The only divisor of this is 1. So, question, how about A, B, and N?
Kung if you know both of them po are relatively prime to N, why is AB relatively prime to N po?
Tama, kasi wala naman silang nag-share ng factor.
Wala po sila nag-share na. So, let's say pa yung A tsaka B composed of 2 and 3. Yung isa po, the N will never, if N doesn't contain any prime factor from A or B, then
Yes.
the combination ng prime factors na yun po will still not be in N. So, they will still not share any primes.
Nice. Okay. So, yun na. Because of that idea, palagi may inverse ka. Parang what we're saying is this. What we're saying is, as long as it satisfies this condition, which is just this one, at mapuprove mo totoo to, so pinapakita mo totoo din yan. Okay? Although we did not write it naturally in a nice proof, pero the argument stays the same. Parang pwede mo siyang iikot. So you start with this idea that if we want to show that there exists an inverse, papakita mo that the product of the two whose remainder is equal to 1. So anong ibig sabihin ng having a remainder equal to 1? So given that if A and B coming from a set that are relatively prime to a particular number, in this case letter n, mapapakita mong product ng dalawa, it's relatively prime to n. Then you will go back, babalik ka dito by saying as well that A has an inverse, in this case, which is B. So, in other words, ibig sabihin, there will always an inverse in this set. So, hindi ka mawawala ng inverse. Ayun. So, any clarification further in this set? In example.
Anong sinabi niyo?
Okay, that's good. So now, may iiwan ako na assignment sa'yo. Bago tayo asan na yung mag-assignment ko? Yan na pala. May properties pa pala tayong tatlo na pag-uusapan before ko ibibigay ang first assignment mo, before we will proceed to subgroups. So 3 properties, actually it's in the book. One is the uniqueness. Although the proof are in the book, so hindi ko na siya i-share sa ngayon. Parang ibig niya lang sabihin is this, property number 1, properties of a group. The first one is that the identity element is unique. So, imposible may dalawa kang identity element for you to have a group. Okay? Second, cancellation law applies. Laws apply. So, dito nang papasok yung naalala mo every time when you have an equation and you have, for example, multiplication or addition, you apply the inverses of these numbers either on the left-hand side of the equation or the right-hand side of the equation. It's the property of the group. So, it will always apply. Okay, the third property na meron din tayo, of course, the uniqueness of the inverse. Ang pagkakaiba niya sa unang property is that meron ka lang isang identity for all and none else. Sa inverses naman, sa bawat number, may isa ka lang inverse and none else. Okay? Because of the definition of the identity and the inverses, magkaiba sila. So sa inverses mo, unique siya bawat number. You don't have parang double inverses for a single number lang alone. Okay? And then finally, itong nice na property, they call this the shoes property. Kasi daw, well, according to some statements, naalala ko to noon, bakit siya tinawag socks and shoes? Meaning to say, mauuna ka magmemedyas bago ka magsasapatos. So similarly, this property that
Actually, pwede pa mag-shoes pa bago pwede pa mag-shoes bago mag-socks, pero kasama lang.
baka kailangan mo ng malaking socks, yung parang pang Santa Claus para makapasok yung pating sapatos.
Yun po.
So in this case, if you take the inverse of a product of two elements of a group, so it follows that you will have B inverse first, tapos A inverse sunod. If your elements are coming from a commutative group, so if A and B are belong to an abelian group, so pwede to babaliktad. Parang distributive yung inverse mo to each of the element. Otherwise, in general, Dapat ito yung property na ipapollow. So the proofs are found in the book. So I'll just leave you to read the proofs of each of these theorems as properties. And I'll give you the assignment for now na gagawin mo. Excited ako sa assignment na to. Okay? So the first one, na bibigay ko na assignment, let me explain. Yung ipapakita mo na this is a group. Okay. First, let's call this SE. SE of 2. SE stands for Special Euclidean. Special Euclidean group ang tawag dito. This is the collection of the following matrix. Cosine theta, negative sine theta, sine theta, cosine theta, 0, 0, letter A, and letter B, and 1. So you have a 3x3 matrix such that yung A and B mo are real numbers. Tapos ang theta mo as an angle will range from 0 to 2 pi. Pero hindi ko lang i-include si 2 pi kasi it's already 0. Pabalik ka in terms of the angle. So, prove that this is a group under matrix multiplication. Okay, prove mo lang siya na indeed this is a group. So meaning you identify, you check if this is a binary operation, yung matrix multiplication, and using these matrices, yung magiging form niya will look like this. Second, associativity, kahit hindi mo nagagawin ang associativity because associativity applies to any set of matrices. But you have to look for, ang identity is easy. So, and then, how about the inverses? Hanapin mong inverse ng matrix na to. Ng mga matrices dito. Okay? So that's your first assignment. May 5 ako in my list. Second assignment. Sorry. Ba't naputol siya. Number 2. Okay, ito. Determine the following. This star is either associative, commutative, has identity, meaning to say yung set where this operation is defined has the identity or has inverses. Susulat ko muna, the following are if 2.1 on the set of rational numbers A times B is equal to 2AB plus 3. So in this example, i-check mo, associative ba ang operation na to? Is it commutative? Kung babaliktad mo, makikita mo yan, obviously makikita mo na commutative siya o hindi. Has an identity, meaning ano ba yung identity under this collection of rational numbers? And how about the inverses? Okay, this is 2.1. 2.2, on the set of integers, if you take the product of A and B, this is equal to A times B plus A plus B. By the way, ang times dito is the ordinary, ang product ng A and B, ordinary product lang yan. Third, dito, on the set of positive integers, A times B is equal to 2 raised to AB. Okay, and then 2.4 on the set of positive integers, A times B is equal to A raised to B. Okay, so yan. Identify mo lang kung associative, commutative. Identify what's the inverse, or what is the identity, and what are the inverses. If it has, kung meron. Okay?
Tama.
All right. That's the second number. Third number. Let S be the set of real numbers, pero i-remove natin yung -1. And let's define, suppose, for every A and B in S, let's define, ang kanina I think define na natin yung operation na to, A plus B plus A times Z. So pareho lang siya kanina actually, yung 2.2. Pero what we will do is you are to prove that S and star is a group. Ayan. So you are to check associativity. Kung napapakita mo na associativity earlier in 2.2, you don't need to show it here. Parang sasabihin mo lang, it was already shown and applied to for any value of S. Okay? Alright.
Tama.
Fourth assignment. Ang dami, no? Good for 1 week. Prove that in a group, A, B raised to the second power is equal to A squared, B squared, if and only if AB is equal to BA. So, we are not saying that the group is commutative. Wala tayong may sinabi dito. For any group lang to. This is true yung distributivity ng squares or ng power of 2 if you have AB is equal to BA. Okay? Specific lang na element. Hindi niya naman sinabi for all AB. So therefore, tapos na tayo na this is ano to? Ng commutative. Wala tayong may sinasabi. Okay, next. Finally, my last assignment for you. This time, you have D4. Which,
Dihedral.
ang dahedral, kanina, ang example natin, which subsets, although this is known in, alam na natin to, makikita mo to sa internet, but I encourage you not to look at the internet, but you can identify, try to identify lang, and wala naman tayong grades dito involved. So identify mo which of the subgroups, subsets of this group, which are also groups. Meaning, identify ka ng mga subsets. Ilang yon? Ilang possible subsets? May 8 kang elements, so 2 raised to 8 ng all the possible subsets. Pero ilan doon yung subgroups, yung groups. And we will be calling this later subgroups.
Tama.
Ayan. So these are the 5 assignments na you can think about for until Thursday.
Bilang po, i-paste ko
paglaruan.
lang po siya sa board po para hindi ko po siya mawala.
Ayan. Okay. Ibibigay ko to. I'll be at the end of my later by 7 p.m. i-send ko to ulit sa iyo. Yung
Okay po.
buong notes na to. Para at least you will have a copy. Okay?
Okay po.
All right. Let us continue lang ang discussion natin. Maybe I'll have 2 items to discuss before let's dismiss. 2 concepts na pag-uusapan natin. This is in chapter 3. Let's concentrate with finite groups by first identifying the order of the group. Ang ibig lang naman sabihin ng order of the group, ilan elements ng group. So let me write this down here. Okay. Order of a group. I'm sorry. Maling ginamit kong pen. Oops. Let me use black. Order of a group. Ang symbol na gagamitin natin, parang counting the number of elements or cardinality, yung parang absolute value.
Opo.
This is just the number of elements of group G. So, nagbibilang ka lang yung element niya. Next, kung meron kang order of a group, meron ka rin tinatawag na order of an element of a group. Order of an element of a group. So, for example, let A be an element of G. A. The order of an element, let's still use the same symbol na absolute value. Okay. This element, let me, instead of letter A pala, I'll use letter G para at least uniform lang yung ano ko. Let us use G, small letter G, small letter G. This is equal to some number N if and only if G raised to N is equal to E, or pwede din sabihin N times G is equal to E. Actually, N to na we are saying it's the least N. Yung pinakamaliit na N that makes your powers of G equals the identity element. So where E is the identity element.
Bakit po kasi yung ano po, identity? Something German din yata rin po eh.
I don't know, hindi ko naalala. Because in this book, kay Galian, gumagamit siya ng identity as E. Yung kay Fraley, gumagamit siya ng letter, ng number 1 for all the identity. Kaya nakakaano yun eh, nakaka-confuse sometimes sa mga books eh. Pero yeah, you're correct. There's an explanation bakit it's E. Syempre, hindi naman wrongly spelled na identity. Identity, parang napaka-corny naman eh.
Pero
Hindi naman, no? Hanapin nga natin, mamaya, let me know. Maybe i-chat mo lang sa akin kung ano yung E na yun. Baka mamaya i-Wikipedia na natin yun. So let's have an example, quickly lang. A quick example from these two definitions. First, let's go back to U, pero ngayon 15. So meaning these are the collections of relatively primes below 15, which are positive integers na relatively prime to 15. Can you help me identify what are the elements of U15?
2, 4, 6, 7.
Tingnan mo 6. Pwede ba si 6?
Hindi po.
Okay.
Kasi hindi
Okay.
pala. Okay, 3, 6, 9, 12. Okay, 15.
Ayun, remove na natin yan.
Tapos
So you have
5, 10, 15 din. So,
tama. So therefore, anong ipapasok natin?
2, 4, 7, 8, 9, 11.
Pwede ba 9?
Hindi pala. So,
Ayun.
4, 7, 8, 11.
Okay.
11 na 12, 13,
13. 14.
tapos 1.
1. Okay, kaya naglagay ako ng space dyan. So the question, what's the order of this group?
1, 2, 3, 4, 5, 6, 7, 8.
Yan, that's the order of the group, 8. Okay. Now next, tignan natin. Let's determine what are the orders of each of the elements. So let's start with 1. Tapos, let's have 2. Let's have 4. Let's have 7. And then, unahin muna natin yung first, first 4. Tapos, let's have 8. Let's have 11, 13, and 14. Remember, the product we're talking about, your group is under modulo 15. Yan. Okay, so first with 1. So you tried ang definition ng order of a group. Again, let's go back. You let the powers increase until babalik siya to the identity element. So yun lang naman ang ibig sabihin ng order. So with 1, how many times you will raise the power of 1 para babalik siya to 1?
1 po.
1 lang. So therefore, obviously, it's 1. Okay. Now next. How about 2? How many times, what will be the power of 2 na babalik siya to the identity and element under modulo 15?
Excluding 0 po na. So,
Oo, yeah.
2, 4, 6, dapat ano siya na, dapat 16, dapat 2 to the 4th power. So, 4.
4. Okay. At for ease lang ng pag-identify natin, can you consider raising each of the elements and identify natin ano yung magiging resulting element? For example, 2 raised to 1. Obviously, it's 2. 2 raised to 2. Obviously, it's 4. 2 raised to 3. So we'll have
8,
8.
16,
So you have 2 raised to 4. It's 16. But modulo 15,
1.
1. So babalik na siya to 1. So that's the reason why you will have 2 raised to 4 mo, yun ang pinaka-least element na n, that it will go back to 1. So therefore, you have 4. Okay. How about 4 ngayon?
4, 16, 2 po.
2. So you'll have 2 here kasi you'll have, sabi mo kanina 4, 16. So may 1, babalik na siya sa 1. So hence, you will have 2. How about 7?
7, 49,
Okay,
300,
7, 49. 49 is what under modulo 15?
4,
4. Tapos, next.
343,
Galing.
Oh.
Modulo 15.
100,
Hindi ko na yan kaya. Hindi ko na yan kaya mentally calculate.
minus 300, tapusan minus 45, negative 2. So, hindi rin siya. So, ano kasi yung closest doon? 30 po na. So, 13 yung modulo niya.
13. Okay. Next.
E43, 2401 yata po. I think so.
Okay. So, you have 1.
So,
Tama.
ayun. 1 na lang po.
Galing. Hindi ko yung kaya. So, therefore, what's the order of this
4
element?
po.
4. Okay. Ang ginagawa ko dito, since I already know na under modulo 4, halimbawa, this is 7, this is 7 raised to the 1 first power, di ba? Ito naman 7 to the second. So you will have 7 to the second. So therefore under module 15, 45, remainder 4. So, ang ginagawa ko lang, multiply ko na lang si 4 with 7. So, I will have 21. So, 428 pala. So, therefore, I will have 13 all in all, yung matitira under module 15. So, 13 na multiply by 7. So, at least maliliit na number yung
Kasi po yung tawag dito, Chinese remainder theorem or something.
Yes, pwede. Although Chinese remainder theorem, meron kang ilang at least dalawa, di ba? Na mga
Opo, at least dalawa po.
Pwede nga may tatlo na modular equations din for the Chinese remainder theorem. Okay, so ito yung mga lista natin. How about 8, 11, 13, and 14? Ito, anong sunod?
So, 8, tapos on 64. Tapos on
So we'll have 8, 64, so we'll have 4. Tapos?
2, ano kasi? 64, tapos on 514 yata.
Module 15, ang laki na yan, ha?
So, try ko po yung method niya. So, 4 times 4 times 8. Modulo 8. So, 0. Okay. Wait lang.
Meron kang 4 times 8 kanina, you mentioned.
32 po yan,
Module 15.
Okay. So, 32, 2.
2, okay.
Tapos isa pang 2 times 4, 8. Ilan ba? So, 16. Modulo 15, 1. Okay.
Okay, so bumalik na siya. So therefore, you will have
4.
Okay, next.
Ano po na, remaining theorem, ano may. So yung ano, yung 11 tapos 121, 1331, alam ko po yun. So dapat, so 1 na. 1331 is that ano? I don't know. I
Ito,
don't know po kung
di ba 11?
11,
Merong
9,
11. Tapos sabi mo kanina 121 na eh. So
no po,
what's 121 under module 15?
120 multiple of 15, so 1 na po yun.
1. Okay, bumalik na sa 1. So therefore, 2. Okay, next.
Baka siguro 4-1 po yan. Maybe. Just maybe.
Sa saan?
Baka 4 tapos 1 po. Yung next. I hope.
Tama. This is 4. And this is actually sunod 2. 2 yan.
Okay.
Okay, so isusulat ko na lang 13, I think 4, 7, and 1. And then you will have 14 and 1. Ayan. So yun. Of course, ito, isa lang siya. That's 1.
This always exists po for any group. Meron po siya laging order.
Yes, lahat-lahat. At may napapansin kang or order of the group at ang order ng element. Anong napapansin mo?
Parang ano po, 8, 1, 1, 1, 2, 4, 8. Parang power po yan.
Yes. In other words, actually, it's the divisors of your 8.
Okay.
So there's a theorem later, pag-uusapan natin, that's called the Lagrange theorem. Maybe nasa chapter 5 pa yun or chapter 6. Pag-uusapan natin na ang mga orders ng group ng ano mo, ng mga elements mo are actually divisors of your 8. So meron kayong makikita. Then later, I'll give you a hint na if we will define what you call a subgroup is just a group which is a subset of a group. Yung kaniyang order of the subgroup is also a divisor of the group. So let me write down the definition na. And I think this will be the end of my discussion today. Definition of a subgroup. Subgroup. Let H be a subset of G, okay, where G is a group if H is also a group, then H is called a subgroup
Okay.
of G. Meron tayong symbol na gagamitin. Rather than subset, ito yung gagamitin natin. Parang less than or equal. To indicate that H is a subgroup of G. Ayan. Then later, di ba, part of your assignment is mag-identify ka anong mga subgroups ng D4 mo. So I'll give you a hint kung anong order nga ni D4, ilang elements niya?
8 yata mo. 8.
8 elements. So therefore, ang mga subgroups ni D4 mo are divisors of 8. So yan. So, yan yung clue mo dyan. Okay, sa paghahanap. So for now, this would be the end of my discussion with you, Joshua. So pag-uusapan natin next meeting, let's continue our discussion about subgroups. So particularly, gagawa tayo ng tinatawag na lattice diagram. After identifying all of the subgroups, titingnan natin anong association ng mga subgroups na to with the bigger group. Pwedeng subgroup mo, mayroong din subgroups. So anong relationship nila? So i-breakdown natin together. But the trivial subgroups, isulat ko na lang dito, the trivial or the obvious subgroups na meron tayo are obviously, of course, your identity element at ang group itself. Kaya meron tayong may tinatawag na proper subgroup, meaning to say it's not equal to itself. So yun yung parang subset din, proper subset, meron kayong identified na proper subgroup, and so on. So this will be our discussion next meeting next Thursday. Let's continue all about subgroups. So for now, do you have any questions, Joshua?
Wala naman po.
Okay. The father of Joshua, may tanong po ba?
Wala po.
So at least for now, thank you very much. So ito lang muna ang discussion natin.
Opo,
So
thank
kung
you.
wala na po, I'll just send this note to you as in parang continuation lang ng note na ginamit natin last time.
Maraming salamat, sir.
Opo, thank you po.
Thank you. See you on Thursday. Bye,
Thank you
Joshua.
very much po.
Thank you po.
Thank you very much po.
Bye.
Okay po, bye-bye po.